All right, I got an awesome Christmas present for myself. This is an Earth, Moon, Sun orrery. Now, I'm an astronomer and I've never heard of an orrery, but I love this gear stuff. I love Legos. I love astronomy stuff. And I'm building it and it's super cool. I'm actually amazed by the engineering and design of all these gears. And what's really cool, Leo, would you mind just kind of turning this for me? What's really cool is that as Leo turns the hand crank, you can see that first gear is turning, which connects to the another gear and another and another. But there's all these gear ratios. And by the time you get all the way to the end, for every time Leo turns the crank, this final piece is hardly moving at all. And it has me wondering, like, how much is this final piece moving? And like, how do people design these things? It's so cool to me. So when I was trying to figure out, well, how much this moving, Leo had a great idea, which is he just started turning the crank and he counted how many turns it took to make this final gear spin once. And he found that it was 25 turns. And I was like, no, dude, we got to use math because this is all about gear ratios. And again, the engineers didn't just start turning the cranks, they actually did some calculations. So what I've done is I've created a little drawing version of this, gearbox and counted how many teeth there are on each of these gears. So for example, the very first gear has 12 teeth. This one has 20, which connects up to this one, which has 8, connects to that one, which has 24, goes down to 8 and 8, and then 40, and up to 16, 16, and 16. And now each time two gear teeth are connected to each other, we have a gear ratio that we can actually calculate. So when that first gear is connected to the gear of 20 teeth, we can express that as a ratio of 12 over 20, which is to say when I turn the crank once, the lower gear only moves 12/20ths of a turn. All right, so I can write it as a fraction. And I can do the same thing now this connects directly with this axle, so I don't actually have a gear ratio there, but here I have 8 teeth to 24 teeth, so I can actually just straight up multiply that by 8 teeth turning gives me, a fraction here of 8 over 24. So if I follow along with all of my gear ratios, I can actually just multiply this out. And this is where the real fun is we get to do some cancellation here. So I can take each of these terms, like 8 over 8 is just 1, 16 over 16 is just 1. So those guys just kind of disappear. And then I'm left with my calculation here. So I'm going to do some simplifying. 12 and 20, I can take a factor of 4 out of that, and that becomes 3 over 5, right, Leo? You can check my math? All right, 8 over 24, I can take a factor of 8 out of that. So then that becomes 1 over 3. Let's see here. 8 out of 40, I can take a factor of 8 out of that. It becomes 1 over 5. Okay, and then there's nothing else. And so I got two factors of 3 here. I can cancel that 3 with that 3. And so my total gear ratio of this whole setup then is, multiply across top and bottom, I just have 1 over 25. So what Leo found experimentally by just turning the crank, I'm actually able to derive from all of these gear ratios. And I think that's super sweet.